Hello and welcome back to Compiler Programming. Today I want to continue with the stack unwinding information, and in particular I want to put it into our executables. So if we compare, for example, the minimal C executable that we have here and what is generated by the mass compiler, then you see that there are this one has this exception directory and ours does not. So this is something that we need to fix. And if you look here, then you see that actually these fields, begin address, end address, and unwind data is exactly the same stuff as with what we created for JIT in the last episode. So hopefully it shouldn't be too hard to fill in this directory. Now, as far as testing it, this is where I'm really not sure if I will be able to do that. I think I will have to then implement also exception handlers, and we'll see if that is something that is going to happen. But for now, the point is we want this exception directory, and we want to put the information there. Okay, so I'm gonna remove what's on this for now. Actually, I need to close down the file, I guess. Yeah, because otherwise it will not be able to compile. So let's check that everything is working, and we are ready to start. Now, additionally, in between the videos, I made a couple of changes to the way we work with the JIT one that should actually make it easier to port this to executable, not just being in JIT mode. And in particular, what happens here is that now all the unwinding information is allocated actually in a data section. And then when we encode the function, we pass a sort of pointer to where we expect the runtime function to be encoded, and the pointer to where the unwinding information is supposed to be encoded. So this means that we can pre-allocate these chunks within the P executable and know in advance what are the sizes of the sections that we need to do. And in particular, unwinding info, it can go into the data section, so there is absolutely no problem for us to add it. It will basically be the same setup as here, where we just will allocate it there. And as far as the rest goes, well, we'll figure it out. So let's try this out. I guess I want to actually open this in a separate window so it is easier to compare and follow what is happening. So we go to program.end here and look at this as a reference, and then can close here, and we can look at our PE32 executable. Okay, so the first thing is we need to figure out where are we putting what. So this thing deals with our data. It actually is incorrect. I think it's just data section, but that's fine. Okay, so we are putting the library names. Actually, no, these are data because this is written things. Basically, we can put our unwinding information into here, I guess. That should not be really a problem. So we will stick it somewhere here. And what happens next? This is the text section, and we have function code. So in here, we'll have to pass the pointers to the runtime functions and the unwinding information. Okay. Okay, this is fine. And yeah, we also need to do this, I guess. So there needs to be exception directory index. I think this is what it's called. Where are these defined? I think I defined them myself, right? Yeah. So there is an exception directory index, and it is 4. So, but it doesn't really matter because we can put them in any order here. So let's start like this: exception directory index. And yeah, we'll put it into our data. I think there is no particular requirement for it to be a separate section. So we'll put it there. We'll say that this is exception directory REA, and then exception directory size. And that's good. I believe it will figure out the number of entries by just dividing the size by the size of the entry. So that's okay. Let's go to our first function and figure out what to put here. So what are we doing? We have expected encoded size, where we are trying to figure out what is going to happen. And I think okay, so let's just add a couple of entries here. So first, each function will have the runtime function. So or exception directory entries. So we say expected encoded size plus equals size of runtime function times the count of functions that we actually have in our program. Okay, so that's one thing. And yeah. And then we have another thing where we are saying that we need to add unwind info. It's like this, or with underscore. Okay, so it's like this. Yeah, that sounds good. So this should give us an estimation, and if we miss it, then there will be a problem. Now, the order in which we do this, I don't think it is actually important. So let's shove it right at the end of all of this. Okay, IIT, product. So we basically have this REA. We will now do the exception directory. Oops, where did it jump? We get REA, and then we do this exception, and here exception. We need to do it in the right order. We also need to add this to these things. So exception and exception. Okay, now things actually should build. Okay, but we are not putting anything here. So let's do that. First, we'll start with the functions because that's probably easier. 64i is 0, I is less than dynamic array length of program functions, and like this. And basically we just allocate like so. but not image import descriptor, but runtime function. Runtime function. And this is the situation where it looks like we will have to either patch things afterwards, which I don't really like, or we will have to change we'll have to change the function encoding to be able to generate these things separately. And that would be preferable, I guess. But that might lead to duplicated logic. So that's an interesting trade-off that I need to think about. So if we open function.c and look at our function in code. So right now, these things are kind of intertwined, and we do need to encode instructions to know the offsets of things here. So I guess what we could do is we could add another section in the executable that will be used explicitly for this data, and that section can actually go after the code, and then we will not be required to patch stuff. What do I need to do? Do I want to patch or do I want to not patch? That is the interesting question. I guess since I do know all the sizes and the pointers to these things will not change, it will not be that terrible to patch things. Let me quickly scan through because I haven't looked at this code for quite a while. So let's see what will happen. So we are writing out section headers, and then we are writing out the data segment. I mean, yeah, that doesn't seem too bad. Okay, so then we need to add a few more things. So we need to have an array of runtime functions, and in reality just a pointer because the size of it will be stored separately. We don't know the size, it's the how many functions we have in a program. So runtime functions, and then we also will have the same for unwind information. Unwind info, or let's put it like this to be more explicit that this is not a single pointer. And then we can do what? Well, I'm actually not sure if it is okay for this stuff to be unaligned. So maybe what I should do here is, to be safe, I will actually align the buffer, but then we might have an issue with the sizing. That's an interesting question. Okay, let's try to not align this and see if it causes actually an issue. Okay, so fix buffer allocate bytes, and then I would say buffer runtime function, so size of and times and the dynamic array length of program functions. Okay, that looks good, and we will need to save it into a result runtime function array is this. Okay, and then we also need to, okay, now that actually ends the directory, but we still need to allocate the unwinding information, which is going to be the same as this. Let's say unwind info array is unwind info. Now later on, we'll be faced with a choice of keeping this calculation simple like this and overestimating how much space do we need for each unwind info entry, because they are actually variable width, or we'll have to make something more complicated, but for now that's fine. We will allocating these two arrays, and we'll see what is happening. So first here is actually semicolon, not comma. And here, yeah, it wants an alignment. For now, I'll just give it the bytes. And we are ready to proceed to the next step. Now, this thing needs to have the pointers to runtime function star runtime function array, and the same for unwind info and info array. And here we will simply pass on the relevant pointers. So unwind info array. And I can find letter I. Cool. So all that's left here is to actually do this. Ooh. I know we prepare our data here, so it's all fine. We say encode it. Let's split it into multiple lines right away. Encoded our data section. Runtime function array and unwind info array. So in theory, if everything aligns perfectly, that should be it, but it almost never is. So let's try to run it. First, let's just run the tests and see what's going on. Okay, so we have already an issue where with our stuff. I wonder. Yeah, okay, I know why that happens, and that actually is an interesting problem. So what happens is, I believe, if we look at this encoding, I'm figuring out the RVA of unwinding by doing this calculation, and that simply is not correct. So what I should be doing instead is unfortunately passing this into here. Otherwise, it's not gonna be right. Or Alternatively, so alternatively, I can just not fill this in here and fill it in outside. I don't know. Both versions are kind of icky, but I guess I'll go for this version. So that means we need function.h and update the signature, where we say that I need to pass u32 unwind data, and here I also need to add the type. Okay. And that means that here I will remove it. And here we'll need to add this. So that's fine. That in this code it should actually work. Result buffer memory, so something like that, and we'll need to actually pass it in. And here in the PE32 code, the RVA. Ooh, that's an interesting question. What would be the RVA of that thing? Well, actually, yeah, here we will be able to figure it out. So what I will do is change this to not pass these things individually and just pass in the pointer to the whole encoded our data section. And then we from there pick up the things that we need. So we go in our data section, encoded our data section. Okay, so let's do this. So runtime function is gonna be now in ampersand encoded our data array, our data section, runtime function array I. That sounds good. Here we'll put in this thing and then unwind info, unwind info. Okay, and finally u32 unwind info RVA is, well, we need to take the RVA of the exception. No, actually, not the exception. We also want find info base, and we want to fill this in. Where will we fill this in? In here, where we are doing this. So our results and find base RVA is get RVA. Okay. And now we are ready to use this. So we put it here and say plus size of unwind info times I. Something like that. We do need to add alignments, I believe. Because unwind info needs to be 30 dword aligned. So do align. So let's get all other kinks out and then fix this, because this should not prevent us from actually compiling the executable, but it will definitely cause other issues when we actually try to use this. They are really unhappy. What are you really unhappy? Because these are not pointers. Okay. Left operand points to struct, use. Okay. Do view argument for a call. That's because I'm missing an info RVA. Okay, what now? From size T to S32. Okay, that's okay. Missing an I here. Not declared identifier. That is because we need to do this. So bind info. So we're just extracting this into a separate variable. Quite easy. Now we can pass it into here. Okay, and finally what? Conversion from U64 again? U64 to U32. Is this a U64? No, it isn't. All of these probably should be U32. I don't know. Yeah, I is U32. Okay, so we just do it like that. Cool. Let's try that again. Okay, all our tests are passing and we end up with hello world here. Also, it looks like our calculations are okay because here we do not assert on this. But before we move forward, I actually do want to align this stuff correctly. That means we'll need to change it here and inside calculations. So before we before we get to here, we need to align. Actually, runtime functions, I don't think it matters, but here we need to do this. So let's say that expected encoded size is U64 align our expected encoded size to size of D word. And info must be D word aligned. And the same will need to be done here. So we just say that buffer occupied. Okay, let's see if we done that correctly. Cool. Now the tough part is that the only tests I can think about right away is just to try to decode this, but it will only test the runtime function information, but let's do that. So now that's going to be very bright, so be careful. And we are ready to check this out. Okay, so first of all, we do get the exception directory, and we do get some information here. So I can zoom this a bit in, I think. So our function starts at 0 and ends at 79, which is not correct, I believe. Or is it? Let me think about this. Yeah, that's not correct, because our text segment is encoded second. So base of code is text section header virtual address. Where is text section header? Text section header virtual address is this. Yeah. So the reason that it says there is because program code base RVA. Yeah, so we have this code base RVAs and our data RVAs, and database. Okay, so we do set these headers correctly. So why is begin and end address incorrect? Because I'm probably not adding it correctly. So when we are encoding these functions, all of these RVAs actually need to be adjusted. So U32 code base RVA, or actually no. So I need to say program code base RVA plus this. This is like this now. All of it needs to be adjusted. Size of prologue, function end. Okay, do we have any more RVAs? No. And it should be fine, because in JIT code, RVAs are now 0. So in JIT code, it should basically do exactly nothing. But in the compiled code, it should make a difference. Okay, I need to close this file, otherwise it stupidly holds onto it. So, okay, what's going on? Okay, I don't have program. So let's actually extract this and use it and do this builder program code base RVA. Just a bit easier to use. And finally here. This will probably fit in one line. Or not. And this can be this for now. Okay, another run of tests. So we didn't break the JIT, which is great to hear. And so let's check again what we have in here. Well, that's much better. So our code, I believe, is at address 2000. and then we have some the size of the function, and this is where our unwinding information is stored. And now we can actually check if we have written out the unwinding information. Unfortunately, that's only going to be really like approximate, let's just put it that way, because I can only see it in hex editors. And so we say div mass build hello world. Okay, that is not working. Okay, so we need the mapping. It says that it's at 1000 BC, but this is a virtual space. We need to convert it into the file address. So we go to data directories, and this is RVA. Actually, no. File elements, actually, no, data directories, directory RVA, yeah. Size of code, size of inference data. So probably at address 2000, okay, yeah, 200, sorry. So here is where we have all of our data stuff, and somewhere over here is supposed to be our unwinding information. And I think, okay, so yeah, 2BC is actually here. So again, what I'm doing is I look at this address. 1000 is its virtual address, and file address will be 200 here. And so it's going to be 200 BC. I'm taking 200 BC. And this stuff is the unwinding information. And if we look at the definition of unwinding, then we can probably even read what it says here. So it says the following. We have 1.4, so version 1. Flags 4. That's, I don't know. That's actually, no, that's just 1 byte. So 1 is just version, flags is 0. Then size of prolog is 4. Okay, so we have a small stack reservation. So we would expect to see unwind code alloc small there. But anyway, count of codes is 1. Yeah, so that is correct for alloc small. We don't have frame register, so this byte is 0. Let me resize this a bit, can I? Yeah. So this byte is the frame register and frame offset, both of them 0. Then we have 4, which is what? So this is 0, this is 1. And this goes into this one. So code offset 4, yeah, that's correct. And then we have 2 in unwind op, and then we have some size in an op info, but I will not try to decode this because it's would be too complicated. But this looks correct. We have it in the section. This section is loaded into the executable. So I don't really see any problem with this, and I think this will be it for today. This is just one more step towards doing the right thing. So I don't think we need relocations directory, to be honest. I think that's fine because, as you can see, it is actually empty. So it definitely is not required for anything functional because it's just for patching at runtime. And debug directory is the next big thing, I guess. And this is going to be very, very frustrating and very annoying. Not because encoding this is complicated, because this is perfectly fine. Like, it's just straight up some text stuff, so that's not an issue. But generating the PDB file is going to be complicated. But that's not today. Today we are done. So thank you very much for watching, and hopefully see you next time.